For question 6d, we're left with the equation of cot x over cosec x minus 1. And that's minus cos x over 1 plus sine x is equal to tan x, 2 tan x. Now the three lines here indicate we need to prove one side equals to the other, and we should choose the left hand side as it's easier to go from this to that, as they're giving us an indication of what to do. What we can first do is get rid of this cot x by using the expression of cot x equals to cos x over sine x. It should make it easier for us to then work out everything and get rid of this cosec x as well, but we'll do that later. So instead of writing cot x, we'll do cos x over sine x. That's all over. Now get rid of this cosec x. Cosec x equals to 1 over sine x. So we have 1 over sine x minus 1. And then we can rewrite the denominator, which is 1 over sine x minus 1. We can rewrite this by making the denominator the same, which is changing this 1 to sine x over sine x. So we have 1 over sine x minus sine x over sine x. This then gives us 1 over sine x over sine x. So now we can rewrite this whole expression as cos x over sine x all over 1 minus sine x over sine x. To make it simpler for us, we can rewrite this as cos x over sine x divided by 1 over sine x over sine x. That's the same as writing cos x over sine x times by the reverse of this, which is sine x over 1 minus sine x. The sine x's will cancel out, so now you're left with cos x over 1 minus sine x. We need to subtract cos x over 1 plus sine x. So we're going to have cos x 1 minus sine x subtracted by cos x over 1 plus sine x. 1 plus sine x. We're going to have to use our knowledge of subtracting fractions, and that's we're going to times these two together, top left, bottom right. So we're going to have cos x 1 plus sine x, and we're going to times the bottom two together, 1 minus sine x, 1 plus sine x. Then we're going to have to times bottom left and top right, so that's cos x 1 minus sine x all over 1 plus sine x, 1 minus sine x. The reason we did that is we had to make the denominator the same, and when you times the denominator by something, you have to times the numerator by the same thing as well. So now we have this, and as the denominator is the same, we can bring everything together. 1 plus sine x minus cos x 1 minus sine x all over 1 minus sine x 1 plus sine x. The only thing we can do from here is we need to recognize that we can expand everything out. So when we expand everything out, we have cos x times by 1 plus cos x sin x, and then cos x minus cos x times by 1 is minus cos x, and then cos x times by sin x, both are minus. That gives us another plus cos x sin x. And over the 1 times 1 is 1. 1 times by sin x is sin x. 1 times by minus sin x, minus sin x. And minus sin x times by sin x is minus sin squared x. And we can simplify this. The cos x cancels out with the minus cos x. And cos x sin x plus cos x sin x is 2 cos x sin x. So that will be our numerator. The sin x is over here, cancel out, so we're going to be left with 1 minus sin squared x. Now they wanted us to give 2 tan x. 2 tan x. Tan x is the same as sin x over cos x. So we need from somewhere to bring this. We can straight away recognize that 1 minus sin squared x is the same as cos squared x. So we're going to have 2 cos x sin x over cos squared x. Cos squared x is the same as cos x times by cos x. And the cos x on the top will cancel out with one of the cos x's on the bottom. So now you're going to be left with 2 sin x over cos x. This is as this cancelled out with one of the cos x's. As we know, sin x over cos x is the same as tan x. We're going to be left with 2 tan x. And that's our answer.